Hello, everybody. Today we are gonna take advantage of a simple mission to get familiar with shader nodes. So the simple mission is to have a screen that would slide. So it's a slideshow system made entirely with shader nodes in order to avoid us to have to timeline, keyframe all the time, slide to the next here, slide to the next here, slide to the next here. We want this process to be automated. So here is a basic scene, just a model of a screen, most basically as basic as possible. And this is an image that just I imported as plain, import images as plain, or with Shift A, image as plain. So it comes with the right UVs of 1, 1. Here you can see 1, 1. So it's distorted, but it's just the way that it imports correctly. So it's 1 on Y, X, and 1 on Y. That will help us for the calculations. The basic process, I shall explain it a bit, because I intend to make this tutorial very beginner friendly. It's just the purpose of getting used to what shader nodes are available, what math nodes are available for us, in order to make something like that. Then in the further tutorials we will attack more advanced stuff. So for the ones who have no time, you can just skip to the start part of the section. Right now I'm gonna explain a bit how we should tackle this kind of mission for us. So we know that there is the time, so we have a time curve, and we will have another variable here. So in our case it could be X or Y, because we want it to slide in one direction. So we will really be glad to have some X or Y variable that we can animate with time. But of course, if we animate it like this, it's just going to keep on rolling straight. So we want a little bit more complex curve. We want a curve that's going to go like this. So meaning that every step here are going to be a change of an image, and every part here is going to be the actual transition of our image. Well, let me explain this better, because in this example I had an easy system that I just don't want to be. So I would have an animation of 0.5, an interval of 2, on a global loop of 5, which means 5 total images. So 1, 2, and tack. 1, 2, and just before becoming 2 seconds, I want it to animate, which means this globally is going to be 2 seconds. This is 2 seconds, and this is 0.5, which means the stagnation point part is going to be 1.5. So we have to understand what, first of all, we always want to see what kind of curve we're talking, this being t, of course. So t and x or y depends, because here we will be able to also change the direction to 0, which means now I can have this animation going on x instead of y. So I want to erase that. And let me get back to my graph. So when we understand that this is what we want, it's going to be much easier for us to separate it into understandable curves for us. So first of all, of course, we want our we're going to have a few steps here. We have to set our images and add them in order, which means that I want this, and oh sorry, I want also our factor variable, which means this factor here is the one that the slideshow is messing with. So this factor is basically, if I set it to 0, I'm 0, and then I slide through my images, and then we go to the darkness, because there's no more images after, and there's no images before. So you can see here the kind of sad part is that I have to repeat this first image and that first image in order to have a nice transition. But aside from that, this factor will help us through our calculations. It remains as a factor between 0 and 5. And after 5, we're going to make it loop back to 0 and to 5 forever. Which means we need our images to be here, and we need those images to be added one next to the other and not one over on top of the other. Not on top of the other. By this basic adding process. And once we have this in our factor, that I should name not color but factor, here, where is it? Here, factor. This factor goes into factor, and then we can set our loop, our interval time. I can put only 1 second as an interval time, and it's gonna go faster, way faster. So we're gonna need this kind of curve. After this, not this, after this, we're gonna need 2 types of curves, which means this is gonna be interval. This is gonna be 2 seconds, 2 seconds, 2 seconds, 2 seconds, and 2 seconds, and for a total of 5 times. And I want, if this is x, for example, I want this to be 0, I want this to be 1 here, I want this to be 2 here, I want this to be 3 here, and 4 and 5, etc. So if we look at this, this looks like this kind of curve, which we don't actually want because it's too linear. So, but we want this similar kind of curve. So let's call this curve a constant curve that goes like this, that has a just jumps to the next increment. So we will want this kind of curve, and we will also want this kind of curve. Let's say this is 1, 2, and then it jumps to here, 2, and it jumps to here, like this, this part, and we want 1, 2, and at 0.5 we want it to go like this. So we also want a curve that does this, tac, tick, tac, tac, tick, tac, tac, and once we have this one and this one, if we add them together, we will have our curve that does this, like we want. Let's start without further ado. So this is what you get when you imported an image with import images as plane, like this, with UVs of 1 on 1. Import images as plane, and while we are here, Node Wrangler add-on. You need to enable it for a few easing techniques that we can use in the shader editor. This is your image. You need to check that this is on clip. it come by default on repeat, it's not going to help us. We need to put the image on clip. Closest can be better than linear in many times, so I like to be set on closest for the image sampling. Now you open your image. Once you imported it, if other images are the same size, you can just drag and drop them here, like I did. They're different, slides 2, etc., etc. So I'm going to call this one slides 1. So slides 2, etc., slides 3, and anything you want. If it's the same size, it's going to fit the same way. Important tip: duplicate this one and put it at the end. Add a texture coordinate node. And plug the UVs on. Plug the same UVs on the second. And add a add color node. A factor of 1. Plug this one in the second. And you see they're overlapping. We want to change that. Add the vector mask. Group it. Remove the first one, transform it to a float value. Add a combine with IV node. Plug this value into the X. And you can combine these as well. Add another variable. Rename the first one value. Duplicate this combine XYZ. Add a mix RGB node. Plug direction into the mix. Combine XYZ into the second. This time put the value into the Y. Take this node, input, output, input, and plug it into the rest. Call this ignored. Now, this is going to add some direction information, X or Y. Duplicate this, subtract 1 out of this value that we don't call vector, we call it factor. And we're going to plug this into the value of the second one, plug the vector in the vector of the one, and this in the second vector. Output. You can call this vector add directional. Repeat the process. But before this, you can plug direction into each and ignored into each. Duplicate. Duplicate this as well. Control Shift D to duplicate with the links. But we don't need the links actually. And here we're going to give the value to each one of these nodes, groups, and plug the rest into the output. Now when you leave this, instead of plugging the two to the same. If we have this and I add a vector mass node here, we will see that on X they have been added one next to the other. Continue the process with all of them. This will be called slides vector. Slides vector. Now we need to do the same process here. Add them all together. I'm gonna add this like this, like this, like this. Add the ones to the first ones. No. Like this. 0 or 1, 0 or 1, 0 or 1, and like this. This factor doesn't need to change because in the add mode it's just going to add them one on top of the other with the black information. We know that it's not going to overlap. You can group this. For once he grouped it nicely, so I just need this to be like this. I have only 4 add nodes, but I have 5 inputs, which means color 1, color 2. Rename that if you please. I like to do it. 3, 4, and 5. Now, if you need to repeat this process, you can repeat this once more. So in order to have this, you want something cool, is to have this next index ready. So you can push this one here and put the original vector in. This vector I will call original, and this I'm going to call next. And these I'm going to rename them. Vector 1, 2, 3, 4, 5. So once I have this, I can just put next here. Vector 1, color, with this, 1. Aha. So this needs to be black. Put this into the first one. So now you will have your last repeating image at the end of the slideshow. It's not here because I did not implement. Next is my factor. It's not my factor. It's my vector, and next should be my factor. Exactly. So here I will factor 0. You see, I can change everything by just changing this factor node. And if I want the direction to be different, this doesn't work because this doesn't work. I don't want X to be changed. Yes. This factor now will work everywhere. In a Y direction instead of the X. I don't need this node anymore. This part is done. set image and add them in order, prepare our factor variable. Now we have to enable time control. Time control, add a multiply node, group it. First value, name it frame, frame. Second, name it frame rate. This one, name it seconds. Add another one. Frame. Add another one. Frame rate. Hash frame to drive this value with the current frames, and frame rate's value to your actual project's frame rate, 25 FPS. Okay, if you have a 60 frame per second, you enter 60 here. Can time info. If we plug this seconds into our factor here and play the animation, it's going to go really fast. Because I'm multiplying, I should divide. And it's still going to just go and not loop indefinitely in the y-axis. I'm going to change this with a modulo node. So if I modulo to, I'm going to input some few value node. This one I'm going to call loop. This one interval. And this one animation. Loop is going to be 5. Like I said, this is going to be 1, 2, 3, 4, 5, and then loop again. 1, 2, 3. The next thing, interval is going to be, in my loop of 5, I got 5, 1, 2, 3, 4, okay. This is my interval, which means if I make a modulo of only 5, this is going to be problematic. It's going to be able to loop only for 1 second, but I want to push this. This is not going to be 1 second. I want this to be 2 seconds, 3 seconds, whatever, this interval. So I'm going to put this interval to 2. So if I want this to be working correctly, I have to multiply here this loop by interval. That's going to give me, for example, if it was 2, it's going to give me a total of 10. 5 times 2, and it will loop back exactly when I will want. Multiply this. Pass this to the factor. And try the animation. Of course, nothing really looks like it changed. So I have to divide it by the actual interval that I had here. And now it's going to take twice longer. It takes actually 2 seconds to roll. So now I have my rolling thing. I need to make this curve. So if it was 1, 1, it would be a curve like this. Now it's 1 to 2, it's going to be a curve like that. But I want this kind of curve, which means Floor can help me do that. Right here, I want my images to just jump to the next image for that curve. And now it's going to work. After 2 seconds, my image jumps to the next. And it's looping forever. Right. So we have one part of the curve that we want. We have this part of the curve. Now we want this part of the curve. That we're going to add this one and this one together, which is going to give us the curve we want. So I already know I'm going to add something at the end of this. What I want to add here is the other part of the curve, the one that goes like this. Which means I'm pushing the value that should be at 0 to somewhere here in the middle, the animation, let's say 0.5. So I want to subtract my animation to 0.5 to have 1.5. So I want this to be here, 1.5, this being 2. So instead of having a curve that goes like this, I'm pulling my curve here. This is a curve that I want. This curve could also be like this. But we know this can be done by the map range node. And map range node has a very important detail. It can clamp us the value, which means now we can get rid of that information and this information, and we will just keep the 0 up to 1.5 and climb up to the top. Map range node is sometimes confusing because you can have the same result by interchanging a lot of these values. But what we know is that this subtract value should be from min, this total value should be from max, and then the incoming value should be perhaps there, this one. But this one not alone. This one still needs to be moduloed again by the interval time, because we still need to have a notion of 0, 1, and 2. We still need to know this. Which means now if I plug this into the add node and come back to start, 1, 2, 1, 2, like this. And now we have our slideshow ready. It's perhaps time to clean up a bit, and we don't need this time info node inside the group. We need this information from outside the group, and nothing here needs to be changed. So you can always divide and floor. You know that this is one part of the thing. You know that this is the other part of the thing. And you know that this is absolutely necessary for him, necessary for him. Once we have this, we can group these values and check that this is not in the wrong order, because this is already in the wrong order, it looks like. This value here. So I subtract my interval, and this is my animation. No, not at all. This is my loop. This is my loop, which should go on top. My loop is here. My value here, my interval is here, and my last value is animation. Animation, animation, interval, interval, loop, loop. 2, I'm going to just repeat it here, 2, and then 0.5. And then I can call this slideshow. Get rid of that. Get this closer. And we're done here. We can do some little things to have a nicer looking screen, because now it looks very flat to me, more like a painting or something. So this should go actually into the emission. And now we will have something that looks more like a screen. We can plug another little nice effect, is to have a viewing angle effect from that screen, which which means it can be achieved with layer weights node, but with this facing value, which is still going to give us some index between 0 and 1, etc. So that we can control something. But I prefer another technique that consists in having the dot product of the incoming vector that you can find in the geometry node, incoming, and divide dot product with the just the texture coordinate one, the reflection code one here. This gives us a value that if I plug into, let's say here, mix RGB of black, I plug this into black, so my emission be either 1 or no emission. Let's kill that for now. I don't want this to be the color, I want this to be the factor. And now you see that we have something happening here. So we are in the wrong side. We want this to be black. Okay, so now we have nothing against everything. But this for me is too sharp, so I'm gonna just add math node and then power it, and add this, and I like to put 2.5 in here, and 0.5 is okay here, and check what's this giving me. And now this is much more soft, the blurring. So I can plug my image back. Okay, let's go back to my main image, and we can see that now we have the reflections. Yeah, if I don't want, yeah, we can have all the reflections. The reflections more than my emission, and my emission clear when I'm sitting in front of it. And it slowly goes back to dark. But this is a good technique, but I also like something extra here, which means having a lighten node and a darken node. So darken is some black, and lighten can have this white. I like to put this to 2.5 and this to 0.9670, and I'm gonna mix those two RGB. I'm gonna mix those two. So I want this one and I want this one to be mixed with that value. So I have to remember here, this is the thing with mix. This is always when mix is equals to 1, and this is when mix is equal to 0. So remember that we were quite inverted for this, which means my color, when I'm sitting in front, it's gonna mean 1, and when I'm looking with a very short angle, it's gonna mean 0. So here too, I want this to be actually at 0, and this to be at 1. And when I plug this back here, yes, I have, so I don't need to be that lighten. Oh, this is not, I can, and this, I forgot. This is the important, the factor. So now I'm hiding almost all the color information when I'm viewing it at a short angle, at a small angle. But I still like to have it exist little bit. So now you have your screen ready to loop, and forever. So you don't have to time frame or keyframe everything in your project. You can just put one screen when if you have to design a mall or a house with a modern iPad, a kind of tablet that are sliding indefinitely, and you can always change your direction here. So you want direction also to be a value somehow. Like this. You can change to 1 when you want and 0. And the interesting thing that I forgot to mention is that what if you want to go in the opposite direction than that? Because it looks like it's only going one side. So you can use the same trick as we did before, a mix RGB, that you will switch with a invert. I like to use invert because this field is going to give me over there a nice sliding thing, and then I get rid of it. I'm okay. This is going to be, if I want to invert this, invert add 1 is going to come here. So I want to, when I'm not invert, go here, which probably I will be. No, it didn't work because invert is at 1. I want 0. And I want to call this invert. And in case I am inverting, I want to subtract here something. What do I want to subtract? I want to subtract my actual loop value of 5. And I want to subtract this from that. And now plug it back here. Which means if I invert, I'm going in the other direction. Okay, so here you are, guys. You can always take this, Control G, and add these values here, 0.5, value exponent, value I'm going to add exponent, name this viewing angle. Name this viewing angle. And here you go. I mean, basically, it's done. You still can group this ugly thing into one. Okay, in case you want to reuse this node, this is vector add directional. Sometimes you want this direction to be something more, so we can still come here, because here we only have this x here. What's going on? Oh, because I'm playing. Yeah. That's not playing. Okay, so I have this x here, this is x, and this is the y. Okay, y. So I also can want the z. So then I will mix again between those two. Z, and the same direction here. I'm going to do the same trick again. Subtract 1 from it. Subtract 1 from it. Okay, keep this one here because this one here is needed, but this one here. Now this gives me z. And I can even make another one that is the Z and the Y and the X merged again. Back here, and then instead of this one, and this one would be the Z, and this one would be the X back again. Which means now I have something from 0, a factor from 0 to 3. So 0, 1, 2, 3. And this is X, Y, Z, and X. Which means if I want to have diagonal stuff, I still can. If I put 0.5, it's gonna be in the XY direction. If I want something else, I can mix between all my directions. It's quite useful. So we're in 2D here because of the UVs and it's flat. So there's no need for the Z, but in case we need it, we can have it. I'm just gonna show you that now if I plug my direction here at 0.5, we're gonna have a slideshow that looks like this, which is not what we want right now, but still we know that we have this direction possible. One other little thing, one other little extra thing that we can do now that we have a nice factor to be able to play with, and we know that this map range is responsible for the animation. We can simply, okay, let's just do something like this, like that. Okay, I guess I got to have some space. We can just come here and add a float curve and try something else. So if this is a regular animation, let me not invert it, and let me have the Y direction, Y, okay, let's say Y, not Y, 1, so we will have this, my float curve. If I imagine I just go with something like that, it will change the whole look of my image transition. That I can lower the factor to be a little bit less. But this is already the right way. I had this good factor from 0 to 1. Now if I plot float curves plugged into it, I can play like I want. What does this gives us? Okay, not so cool, but kind of easy to play with. So I even have on my own this expo node that I can plug here, position, and this is this gonna work? Duration should be 1. Duration is 1. Yeah. So now I have this this thing that is transitioning exponentially in. If I want it to be exponentially out, it's gonna go like this. So it's quite useful. It's doing the similar thing to that, but I mean exponential curve would be somehow looking like this. This is kind of an exponential curve. But somehow here the rounding is not always perfect. While this is mathematically calculated, so I mean it's like this kind of weird mathematical stuff like this. So since it's only mathematics, it's much more smooth. That's why I like to use them, but I didn't create them all yet, so I only have expo, but it's still fun. I can also have 2 in and out. This is if I put it back to 1, it looks quite nice, like this. I'm also going to put the project files in the description for people who are interested, or simply don't have time. But give it a try. These shader nodes are very powerful, and they can help you understand a lot when it goes to geometry nodes afterwards. It's the power of proceduralism that can sometimes save you a lot of time later on. Anyway, it was all cool. Yeah, just like this. And one last thing is that you always need this node to be always on at the end. So if you want to add more images, you always can, like duplicate, like here, because we made it 5 vectors, 5 each. We can always add a lot of 5 blocks, 5. I mean 5. I like it because it's kind of a useful number. So if you have a slideshow of many more images, you just duplicate these images, and you don't forget to put this one at the end, like not original vector, this vector. The last vector should be this image always, and here too, like this. But that's it, I believe. Thank you guys for having watched it so far. I hope this was not too beginner friendly for you and you got bored, and you always can skip next to go to your valuable information. I don't mind. You can leave a comment. It's my first tutorial, so I didn't want it to make something too advanced or too crazy fast. I wanted to make sure, because my friends are gonna watch also, I want them to see how is the workflow with the geometry nodes, shader nodes in the meantime. But I hope you enjoyed so far, and remember that Blender's shader nodes and geometry nodes are so cool. It's powerful. Anyway, bye bye.